AB is a tangent to the circle CDE, center F at C. Calculate the value of X. And so notice that we have angle X right here. This is the angle at the center. And our goal is to determine what is the size or what is the value of angle X. Now notice that this theorem states that the angle at the center of a circle is twice the angle at the circumference. And so if the angle at the circumference is X, then the angle at the center is 2 times X. And so what we have here is we have the angle at the circumference, which is 55 degrees, and we need to determine what is the angle at the center. And so in order for us to do that, we're going to say angle X, which is the angle at the center, is going to be 2 times 55 degrees because the angle at the center is twice the angle at the circumference. So we have 2 times 55 degrees, and 2 times 55 degrees is going to be 110 degrees. And that's because of the angle at the center theorem. Now, we already know what angle X is. It's 110 degrees. Now we need to determine what is the size of angle Y. In order to do this, we're going to use the alternate segment theorem. And the alternate segment theorem states that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Now, what that means is that notice that we have this chord AC, right? So this is the chord AC, and this is a tangent, right? The angle that lies between this tangent and this chord is theta, and that means that based on this theorem, theta is going to be equal to this same angle here that is subtended by the very same chord in green. Now we know that this angle is subtended by this chord because the legs of this angle rests on the green chord. And so this is the theorem that we're going to use in order to answer, in order to determine the size of angle Y. Okay, so what we have, right? We have the tangent, right? So this is the tangent line right there. So this is a tangent. And we also have a chord, all right? So this is your chord right there. So this is our chord right there. So we have the tangent and we have the chord. And we have, so let me do this right now. And then we have the angle that is in between the tangent and the chord. What is that angle? Right? That's angle, let's put this right now. That's this angle right there, right? This angle, angle Y. This is the angle that is in between the tangent and the chord, all right? So we have this angle right here, angle Y. So we have this tangent and we have the chord, and this angle Y is the angle that lies between the chord and the tangent. Now, what does the theorem says? The theorem says that this angle is going to be equal to this angle that is subtended by the very same chord in yellow. And we know that this angle is subtended by that chord because we know that this angle that measures 55 degrees is subtended by the chord in yellow because the legs of this angle rests on the yellow chord. And so that means that this angle right here is subtended by the same chord, right? The same chord that is used to form this angle with the tangent line. And so what does that mean? That means that just like how this angle is 55 degrees, angle Y is also going to be 55 degrees as well. So the answer here is 55 degrees based on the alternate segment theorem. Next, we need to figure out, okay, what is the size of angle Z? All right, angle Z. Now, what do we know already? Well, we know, well, what do we know already? But we know that angle X, right? Angle X is 110 degrees. So this right here is 110 degrees, all right? And we know that based off of the first question that we answered. But we need to figure out what is the size of angle Z, right? If we look carefully, we're dealing with a triangle, right? We're dealing with a triangle. And if we notice carefully, right? If we notice carefully, let me erase this. If you notice carefully that this right here starts at the center, all right? That's the center, and ends, and this line starts at the center and ends at the circumference of the circle. So this would be what we call a radius of the circle. And this line starts at the center and ends at the circumference, right? And we call that also a radius, all right? And so both of these chords or both of these lines are the radius of this circle, which means that these two lines here are equal. Now, if these two lines here are equal, what does that mean? Well, that means that the two sides of this triangle are equal. And so that means that what we're dealing with right here is we're dealing with an isosceles triangle. So this triangle right here is an isosceles triangle, which means that not only are the two sides are equal, but it means that the two angles are equal. So if this is angle Z, that means that this must also be angle Z as well, because we're dealing with an isosceles triangle. Now, what do we know? Well, we do know that X is 110 degrees. And we also know that angles inside a triangle add up to 180 degrees. And so what we're going to do is we're going to take 110 and subtract that with 180. And then we're going to, whatever our result is, we're going to divide it by 2 because these two angles are the same, all right? And so that's how we're going to figure out the size of Z. We're going to say 180 minus 110, right? And whenever we get our result, we divide it by 2. And when we divide it by 2, we get, so we have 70 divided by 2. And we have to divide it by 2 because we have to take 70 and split it between these two angles. So we have 70 divided by 2, which is going to give us 35 degrees. So that means that this Z right here, that means that Z is 35 degrees, all right? And it also means that this Z right here is also 35 degrees, all right? And that makes sense because if we take 35 plus 35 plus 110, that gives us 180, and angles inside a triangle adds up to 180 degrees. And so the size of Z is going to be 35 degrees, and that's because angles in a triangle add up to 180 degrees. And that's our answer to this question.